Welcome to The Explainer. There's this universal truth in software development. A massive chunk of our time isn't spent on the cool, new, exciting features. Nope. It's spent on the often frustrating grind of fixing and maintaining the code we already have. Today, we're going to explore 4 modern tools that are designed to help you get that time back and turn that daily grind into a state of creative flow. Well, think about it. Code isn't just about getting the syntax right, is it? It's this complex web of logic that has to be correct, it has to be understandable, it has to be fast, and it needs to be able to scale. That's where all the real work and honestly, all the frustration really lives.
But what if we could just streamline that entire process? We're about to dive into 4 really powerful tools that target these exact headaches, helping you catch bugs way earlier, write code that actually makes sense later, and build out your applications with some pretty incredible efficiency.
Okay, let's dive into our first problem. The easiest bugs to fix are those little syntax errors, right? Your code editor just screams at you immediately. But the really dangerous ones, the ones that keep you up at night, are the logical bugs, where the code runs perfectly fine, but it gives you the completely wrong result. These things are silent, and man, can they be costly. So this is a super classic example of what I'm talking about. Let's say you write a function to add 2 numbers. Simple enough. But what if, somewhere else in your app, those numbers get passed in as text, as strings? Well, your code runs without a single error, but all of a sudden 1 plus 1 now equals 11. That's a logical bug, and it can slip by completely unnoticed until it causes some major problems down the line.
So how do you catch something like this? You're not going to wait around for a quality assurance team to find this manually, right? The solution is automation. You use a powerful framework called PyTest to drive a process we call test-driven development.
Now, with test-driven development, you basically flip the whole process on its head. First, you write a really simple test that just says, hey, I expect that when I give this function a 1 and a 1, it better give me back a 2. Of course, that test fails because the function doesn't even exist yet. Then you write just enough code to make that one test pass. You see, you're defining the correct behavior before you even write the logic. So ultimately, PyTest becomes your personal safety net. Once you've got a whole suite of these tests, you can go in and refactor and improve your code with total confidence, because you know that if you accidentally break something, a test is going to fail immediately. I mean, this saves countless hours of that painful manual checking, and it empowers every single developer to validate their own logic instantly. All right, let's move on to the next big frustration. And look, we have all been here. You're looking at code you wrote maybe 6 months ago, and you have absolutely no idea what it does or why you wrote it that way in the first place. The fix here is all about understanding the huge difference between comments and something called docstrings. Comments, the ones with the hash symbol, they're like little notes to yourself. They explain the tricky how of the code. But docstrings, the ones inside triple quotes, they're the official documentation. They explain the what the function does, what inputs it needs, what it gives back. And crucially, they are machine readable. So, a well-written docstring like this one acts as a built-in user manual. It spells everything out: the function's purpose, the parameters it takes, what it returns. Now, when another developer, or let's be honest, you in the future, hovers over this function in their code editor, all this information just pops up. It explains how to use it correctly without them ever having to read a single line of the internal logic. Okay, so this whole docstring thing, it leads us directly to the next big evolution. It's got this powerful secondary benefit. It helps us tackle one of the most time-consuming parts of coding, writing all that repetitive boilerplate code. The predictable structural stuff you find yourself writing over and over and over again. So, remember that docstring we just wrote? Well, guess what? It's not just for humans anymore. In today's workflow, it becomes a direct instruction, a prompt for an AI coding assistant. Yeah, you heard that right. You write the docstring describing what you want the function to do, and tools like GitHub Copilot or the free AWS Code Whisperer will read it and literally generate the entire function for you. And we're not talking about a tiny little boost here. Studies are showing this can ramp up your coding speed by as much as 55%. It's wild. You describe, it writes. Okay, so we're testing our code, we're documenting it, we're even writing it faster with AI. Awesome. But what about when you need to share it with other applications? Well, that means building an API. And historically, that comes with its own set of massive challenges. You got to make it fast, you have to document it for everyone else, and you need to validate all the data coming in. And the solution is a really slick, modern Python framework called FastAPI. And just like the name says, it is all about speed and simplicity. And it's designed to solve these classic API problems right out of the box. What's so great about FastAPI is that it just handles all the hard stuff for you. You don't have to worry about it. It's ridiculously fast because its core is built in Rust. It automatically generates interactive documentation for other developers to use. And get this, it automatically validates incoming data, which prevents that exact 1 + 1 = 11 bug we saw at the very beginning. I mean, just look at this, seriously. In 4 lines of code, 4, you have a fully functional, high-performance web server. This level of simplicity is an absolute game changer. It lets you focus on your application's logic, not all the plumbing underneath.
All right, let's pull back for a second and see how all 4 of these tools really weave together. This isn't just about using one tool in isolation. It's about adopting a totally modern workflow where each step supports the next, turning all those points of friction into a seamless state of flow. So think about the workflow, right? You start with PyTest to write your tests first, making sure your logic is solid from the get-go. Then you write a really clear docstring to document exactly what your code is supposed to do. That docstring then becomes the prompt for your AI assistant to just write the code for you. And finally, you wrap the whole thing up in FastAPI to create a fast, documented, and super robust API for the world to use. Each tool solves a specific problem, creating this powerful, compounding effect on both your productivity and the quality of your code.
Look, at the end of the day, this is about so much more than just a bunch of cool new tools. It represents a pretty fundamental shift in development itself. The focus is moving away from manually writing every single line of code and moving towards designing systems, defining behavior with tests and prompts, and leveraging AI as a genuine co-developer. So the real question I want to leave you with is, are you ready to adapt your workflow for this new era?